Hey Blake,
Hello.
how are you tonight?
Good, how are you?
Good. So what are we doing tonight?
Um, Same stuff, cause I haven't had school the past 2 days, so
Oh, you got 2 days off. Where did
yes.
you go to school?
Douglas County.
Huh? They had both days off, huh?
Yep.
I'm surprised because today I was out and about. The roads weren't bad at all. They were
Yeah, we had both
almost
days.
clear. Yeah. Do you have some problems to go over?
Um, yeah, I think I have a few, but
Okay. Well, give me
let's
a
see.
few and maybe I can expound on them if I,
Okay.
I don't know. Let's see exactly what you're doing.
Okay, I think this is one we haven't done.
Okay.
Alright, y equals 4 parentheses x minus 8 squared minus 4.
And your job is to graph it? What
Yeah.
kind of format is that in?
Vertex.
Yeah, it's worth recognizing the format because if it's in exact vertex format, tell me what the vertex is.
8 negative 4.
I'm going to call that point right there 8, negative 4. Should open up or down?
Up.
I'm just going to approximate it because I don't know what these points are. What's the easiest way to get 2 additional points? I'll let you tell me.
Um,
You usually have 2 choices. You can solve for the Y-intercept and then figure out what the third point is, or you can solve for both X intercepts. Sometimes one's easier, sometimes the other's easier. I would suggest for the moment that you do both, just so you get familiar with both of them. Solve for the Y-intercept.
um,
What's X equal to?
0.
Okay, so solve for the Y-intercept.
It would be, 60,
Okay.
60? Yeah, 60?
64, 8 squared, negative 8 squared is 64,
Yeah, but
times
minus 4.
4. No, next times 4. In other words, here's what it is. Right?
Mm-hmm.
All I did was substitute 0 for x. Okay, that becomes this. That's 256 minus 4, 252. That is the y-intercept. So let's pretend I got a nice big graphing thing here. Tell me what this point is right there.
That's 0 to 52.
And there's a point over here that is perfectly symmetrical. What is the coordinates on that point? Give me the easy one first. What's the y-coordinate?
The y coordinate would be 252.
Okay, now the harder one is the x-coordinate. It's not that
Mm-hmm.
hard though. Here, I'll give you a hint. First of all, do you know what it is?
Um, Wait, would it be, um, So it'd be negative, wait, no, it'd be 16.
Perfect. The hint I was going to give you was this line, which is the line of symmetry. It's not drawn, it's imaginary, but it's a vertical line that splits that parabola perfectly in two so that everything is symmetrical about it. So that distance, which we know is 8, has to be equal to that distance. That has to be 16. Okay? Now, let's find two other points. Just occurred to me why teachers ask for 5 points. Because they want you to do it both methods. Okay? In other words, now I'm going to find this point and this point, the X-intercepts. So, how do I find the X-intercepts based on that formula?
You just, I don't know.
There's one thing that's really important to realize about the XY plane. What's the Y value when you're on the X-axis? No matter where you're on the X-axis.
0.
What's the X value when you're on the Y-axis? No matter where you're on the Y-axis.
0.
Okay. So if I'm solving for the X-intercepts, what am I going to set Y equal to?
0.
Now, we just have to solve this. And it'll give us both X-intercepts. Help me solve that.
You do 4x plus 64.
No, you don't do it that way.
So it'd be.
Let me give you a hint. You're going to solve this by taking the square root of both sides at some point. And if you're going to do it that way, then the last thing in the world you want to do is expand that x minus 8. In other words, it's already factored for you. And there's no x term anywhere. So all I got to do is isolate. So all I got to do is isolate that part right there. And then I'm going to take the square root of both sides. So how do we isolate that part?
You just do x squared.
Nope. You don't do anything with it. Leave it alone. Get rid of everything else. I got a minus 4 over here I got to get rid of. And then I got a leading coefficient of 4 that I got to get rid of. That's how I isolate that. Okay? So how do I get rid of the minus 4?
You add 4.
How do I get rid of the multiplier of 4? Something multiplying, how do you get rid of it?
Divide.
Okay. So now I got 1 equals x minus 8 quantity squared. Now this is the point that I'm trying to get to. Because now I don't have to expand it and turn it into a quadratic. There's a much easier way to solve it. And that's by taking the square root of both sides. So what's the square root of the right side?
The square root of the right side would be x minus 4?
X minus 8.
X minus 8.
Yeah, in other words, when you're taking the square root of something squared, it's x. If I'm taking the square root of this, then it's whatever this is. The square root undoes the squaring. So whatever is being squared is what's left. Always. Okay? What's the square root of the left side? Started out as 1.
The left side would be 1? What?
It's plus or minus 1. The rule I try to get students to believe is that if you are solving an equation by taking the square root of both sides, always, 100% of the time, let your answer begin with the words plus or minus. Because most people don't put it in there, they forget. Notice that minus 1 squared is 1. So is plus 1 squared, it's 1. So the square root of 1 is plus or minus 1. Now, solve for x. There's two different values for x. What are they?
Oh, it would be just wait, what?
Okay, here, let's do it. No, let's do it this way. You need to know how to handle this plus or minus. So to solve for x, what do I got to do, first of all?
Add 8.
Okay, so I've got plus or minus 1 plus 8. That's what x equals to.
Mm-hmm.
Now, that's two different answers. It's plus 1 plus 8, which is what?
9.
And it's minus 1 plus 8, which is what?
7.
Those are your two answers. So this coordinate right there is 7, 0. And this coordinate right there is 9, 0. And it wasn't too bad. We didn't get any fractions or radicals or anything. And you need to get good at solving those kind of equations. This is just simple algebra once you get it set up. And I do believe that this probably is the way you should go in this problem. Only because the Y-intercept is such a big number, 252. Doesn't make it a bad point. 3 points do define a parabola, without a doubt. And it doesn't matter where they're at. You give me these 3 points and tell me it's a parabola, and I'll give you the equation of that parabola. Okay? But your 3 ideal points are your vertex and probably your X intercepts. The Y-intercept can be important also, but you can see there's two totally different methods to find those 2 additional points after the vertex. That was a good one because we got to cover how to find your X-intercepts and your Y-intercept. Okay, what else?
Let me see if I can find one.
Yeah. See if you can find one that's not in vertex format, just so we can try a different format.
Okay, here's one. So y equals 2x squared minus 12x plus 6.
Okay. What's the first thing you notice about this quadratic?
It's in standard form.
Okay, that's good. So, what are we inclined to do with this?
What do you mean?
Well, we could factor it. We could use the equation, the x coordinate of the vertex is minus b over 2a, which I would normally do. But let's just see if we can factor it, because if it factors nicely, then it's in X intercept format. And that's really easy to grab. Okay? So what's the first thing we're going to do if we decide we might take a shot at factoring it?
You want to do
All even.
two.
We're looking at all even numbers.
Oh, take out a 2.
Okay. That always going to make it easier. It always reduces it to a first level quadratic. Now, I can tell by looking at that I'm not going to be able to factor it because 3 and 1 are never going to get you to 6.
Mm-hmm.
So I can't factor it without using the quadratic formula. I could use the quadratic formula, but then it gets a little messy and your X intercepts are radical numbers. So let's go back. Now that I've discovered I can't factor it, now I got two choices. I can complete the square to try to get it into Vertex format. That's not a bad idea. Let's try that, because you haven't had any practice in completing the square in a while. And I think you'll see why this is going to work nicely. If I'm going to complete the square, I want to isolate the x squared and the x term. Notice I haven't changed anything. Right?
All right.
I multiply everything back together again, I got exactly what I started with. Okay. Now, all we have to do is complete the square in the middle and balance it on the same side of the equation so that I don't change anything. And we're going to have it in almost perfect Vertex format. How do I complete the square? And this is something you need to remember because there are lots of different places where you have to complete the square in math. It's really an easy process. You just have to remember how to do it.
Okay.
You take half of the coefficient of the x term. You square it and you add it inside those parentheses. So tell me what to do. Take half the coefficient of the x term.
So 1.
No, coefficient of the x.
0.5.
No.
3? Wait, -3.
Yeah, the coefficient of the x term is 6. Right?
Right.
Coefficient is the number that is in front of a variable. The coefficient of the x squared term is 1. Coefficient of the x term is -6 if you want. So I'm going to take half of -6, which is what?
-3.
And square it.
-3 squared.
Plus 9. And I'm going to write that plus 9 right in there, and I'm going to do it in blue because I'm changing the equation now. And I don't want to change the equation. The equation was this. I just changed it. How much did I add to the equation?
3? What?
When I wrote this 9 in, all on my own, how much did I add to the right side of that equation?
9.
Actually, 9 times 2. See that 2 that's factored out?
Oh, yeah.
So really, I added 18. So I have to subtract 18.
Mm-hmm.
Nothing happened to the 6. Let me put that back in red. That's still there. I didn't do anything to it. But I definitely added 18 when I wrote in that plus 9. Well, I want to keep that thing exactly the same. I don't want to change it. It's the same quadratic. This is now the exact same quadratic that I started with. And that's the whole point when you go from row to row. The only difference is that now I can write it in perfect Vertex format. The whole reason that you complete the square is so that you can write it as a linear term squared. When you took half of 6, that's what goes right there. Okay? And now I combine those two numbers and I got minus 12. Look familiar?
Yeah.
Vertex format. So I've taken standard format and I've converted it to vertex format just by completing the square. I know it seems hard, but you want to remember completing the square. It's just not the last time you'll have to do it. Now, tell me the vertex. Let me erase some of this stuff so I have some room to work with.
312.
Okay, good. 3 and what?
12. Negative 12.
Negative 12. Okay. Open up or down?
Up.
Now, I'm going to draw it in, even though I don't know my other 2 points yet. And I don't know where that y-axis, whether I'm drawing it correctly or not. I'm just drawing it to notice that I'm pointing up, not down. Okay, now we need 2 points. This case, I'm quite certain that this point and this point will be the easiest ones to find. But, yeah, let's find those first.
Which one? Oh, those two? Okay, so it would be,
That's no longer our equation. This is down here.
yeah.
Same equation, but just in a different format.
Alright, so the y-intercept would be, would be 4.
How do you get the y-intercept?
Plug in a 0 for x.
Okay, let's do it. Y-intercept is 2 times 0 minus 3, quantity squared, minus 12. What is that?
That would be,
Do it piece by piece. Do it according to PEMDAS.
okay, so it would be 9.
Always do that first. Do your parentheses.
Be 9.
Okay, multiply it by 2.
18.
Subtract 12.
6.
Okay. So, notice that the way I drew it is not correct. But it doesn't matter. We solved for the y-intercept. So, just so that you understand, let me redraw it. I know the y-intercept's right there now. So it's got to look something like this. It's just a very skinny parabola. Okay? Now, what's the coordinates on that point?
That one, it would be,
It's the x-coordinate.
it's the x-coordinate.
What is the x-coordinate? What's the y-coordinate?
6.
Right there. Y-intercept is 6. Now, what's this point over here?
It'll be 0, 12.
Does it look like 0?
No. It would be, hold up, so that's, would it be 6?
Good. It's the second.
And then the second one would be 12.
Is it the same y-intercept as what its opposite?
Yeah, 6 and 6.
Okay. So, That's a good place to stop. I do have a 7:30 I have to get to. If I had a little time, we'd go back and find these x-intercepts also. And we would do that by setting y equal to 0 and solving that equation. Okay? Blake,
Okay,
we're making progress. We're getting there. Huh?
Yep. Yep.
Okay. I'll talk to you next time.
All right, thank you.